Good morning to all. I am G.A. Hegde, working as Associate Professor, Department of Chemistry, KGF State College, Urgaon, KGF. Today, we shall discuss about the fifth session of Metallurgy. This chapter is included for third semester BSc, Bangalore North University. In this session, we will discuss about the sources of uranium and plutonium, concentration of ore of uranium, extraction of uranium from pitchblende, and isolation of plutonium from uranium. Production of plutonium from burnt nuclear fuel. After studying this, you will understand about the sources of uranium and plutonium, extraction of uranium and isolation of plutonium, also separation of uranium and plutonium, and the importance of uranium and plutonium. In order to understand this, you must have the knowledge of nature of the ore, method of concentration of ore, method of purification of metal, and about burnt nuclear fuel. With this, let us discuss about uranium. It is represented by the symbol U. Its atomic number is 92. Atomic weight is 238.03. Electronic configuration is radon configuration 5f3, 6d1, 7s2. Valency +4 and +6. Occurrence. Uranium is radioactive element. It does not occur in free state. The important minerals are: number 1, pitchblende, having the composition U3O8. Number 2, carnotite, having the composition K2O, 2UO3, V2O5, 3H2O. Number 3, autunite, having the composition Ca, UO2 twice, PO4 twice, 8H2O. Extraction of uranium. Uranium is extracted from pitchblende. It is concentrated by gravity separation method to remove sand, clay, etc. Then the concentrated ore is roasted with excess of air to remove volatile impurities as their volatile oxides. Silver, if any present, is removed as silver chloride by heating with sodium chloride at 800 degrees Celsius. The roasted ore is digested with dilute sulfuric acid in presence of manganese dioxide for about 24 hours. Uranium goes into solution as uranyl sulfate, whereas others are precipitated as respective sulfates. U3O8 plus H2SO4 plus O2 gives rise to UO2SO4 plus H2O. Uranyl sulfate present in the solution is concentrated and converted to sodium uranyl carbonate by reacting with sodium carbonate. UO2SO4 plus Na2CO3 gives rise to Na4UO2CO3 twice plus Na2SO4. The solution containing sodium uranyl carbonate is neutralized with hydrochloric acid to uranyl chloride and then saturated with hydrogen sulfide gas to remove impurities like lead, copper, etc. as their respective sulfides. The solution of uranyl chloride is reacted with excess of ammonium hydroxide to get precipitate of ammonium diuranate, which on heating with air gives U3O8. The equations are Na4 UO2 CO3 twice plus HCl gives rise to UO2 Cl2 plus NaCl plus H2O plus CO2. UO2 Cl2 plus NH4OH gives rise to NH4 twice U2O7 plus NH4Cl plus H2O. NH4 twice U2O7 gives rise to NH3 plus U3O8 plus H2O plus O2. The U3O8 is reduced to UO2 by heating with hydrogen. The equation is U3O8 plus H2 gives rise to UO2 plus H2O. Further reduction of UO2 to uranium with hydrogen is not possible even at very high temperature. UO2 is heated with hydrofluoric acid at 670 to 770 Kelvin to get uranium tetrafluoride. UO2 plus 4HF gives rise to UF4 plus 2H2O. UF4 is reduced to uranium metal by heating with magnesium. UF4 plus 2Mg gives rise to U plus 2MgF2. The next element is plutonium. It is represented by the symbol Pu. Its atomic number is 94. Atomic weight is 244. Electronic configuration is radon configuration 5f6 7s2. Valency is +4 and +6. Occurrence. Plutonium does not occur in free state and produced from uranium. It is also present in trace amounts in uranium ores. Production of plutonium from nuclear fuel. It is mainly obtained from uranium in nuclear reactors. Natural uranium contains very large amount of uranium-238 isotope up to the extent of 99.2%. By the interaction of slow neutrons with uranium-238, plutonium is obtained. The equations are 92U238 plus neutron gives rise to 92U239 plus gamma radiations. 92 uranium-239 gives rise to 93 neptunium-239 plus beta particle. 93 neptunium-239 gives rise to 94 plutonium-239 plus a beta particle. Plutonium is separated from uranium chemically. Plutonium undergoes nuclear fission reaction in the same way as 92 uranium-235 undergoes. Production of plutonium from burnt nuclear fuel. Plutonium is mainly obtained from uranium during nuclear reactions. Some products obtained during the fission reactions are neutron absorbers and stop the chain reaction before the completion of 92 uranium-235 and plutonium 94-239 has been completely consumed. Therefore, the irradiated fuel is removed regularly from the reactor and the fission products are separated. From this, the plutonium is recovered. The spent nuclear fuel is immersed in cold water for several days. During cooling process, elements like iodine 131 lost their activity and materials gets cooled. It is then dissolved in 1 normal nitric acid to get solution of plutonium 4 and uranium 6. It is then extracted with 20% tributyl phosphate in kerosene. The TBP extract is reacted with aqueous ferrous sulfate solution. Plutonium 4 is reduced to plutonium 2, which passes into aqueous phase. The aqueous solution is oxidized with nitrous acid to get plutonium 4. It is precipitated as plutonium oxalate by reacting with oxalic acid and ammonium oxalate. The plutonium oxalate is dried and ignited to get plutonium 4 oxide. The equation is Pu C2O4 twice plus O2 gives rise to PuO2 plus CO2. The plutonium oxide is reacted with hydrofluoric acid in presence of oxygen to get plutonium tetrafluoride. PuO2 plus HF gives rise to PuFO plus H2O. Plutonium tetrafluoride is reduced with calcium to get plutonium. PuFO plus Ca gives rise to Pu plus CaF2. After studying this, let us recall what we discussed so far. We discussed about study of sources of plutonium and thorium, extraction of thorium and plutonium, refining of plutonium and thorium, and also importance of plutonium and thorium. With this, let us try to answer some simple questions. The first question is, the composition of pitch blende is? The correct answer is D, U3O8. The second question is, the isotope of uranium used as nuclear fuel is? The answer is C, 92 uranium 235. The third question, the uranium tetrafluoride is reduced to uranium by heating with? The correct answer is A, magnesium. The fourth one, the isotope of plutonium used as nuclear fuel is? The answer is A, plutonium 94 239. And the last is, plutonium is obtained by the reduction of plutonium tetrafluoride using? The answer is D, calcium. In order to prepare this, I have referred these textbooks and also sources from internet. For further details, you can also refer these textbooks and internet. Thank you.